Good morning friends. Today we are going to discuss one of the non-traditional machining process, that is electric discharge machining process. Okay, in this video we will describe about the different parameters and a different process and a total description of EDM process. Okay, so before going to these slides, I am going to give a little bit idea about this topic so that I can generate your interest towards my topic. Okay, so let's see what is EDM. This EDM process or electric discharge machining process. Okay, so what do you mean by EDM, electric discharge machining process? As the name indicates, M means here we are telling electric discharge machining. Electric discharge machining. Okay, so this is one of the machining process. Machining means machining can be divided into traditional and non-traditional machining. Okay, this machining can be divided into traditional and non-traditional machining. So what do you mean by traditional non-traditional machining? Traditional means general basic. In another video I will describe about the traditional non-traditional machining. So one main idea thing is, in case of traditional machining there is direct contact between tool and workpiece. Okay, tool and workpiece will be direct contact during machining of traditional machining. But in case of non-traditional machining there is no direct contact between tool and workpiece. There will be no direct contact between tool and workpiece in case of non-traditional machining. This non-traditional machining can be divided in different types, just like thermal material removal, mechanical material removal, electrical material removal, chemical material removal process, like this. So this is one of the thermal material removal process. This EDM process is one of the thermal material removal process under non-traditional machining process. Okay, so then this is the machining. The name indicates this. Okay, then electric discharge. What do you mean by electric discharge? This means a spark. Okay, electric discharge means nothing but a spark. So here spark is generated due to the spark high heat created. Due to the high heat, material will melt and evaporate. Okay, and the machining is occurred. This is the technique. So then go for a basic concept. Generally in case of traditional machining there is direct contact between tool and workpiece. So similar to this, here this is workpiece. Okay, and here there will be one tool. Okay, this is the tool and this is the workpiece. Okay, and in between this there will be spark and material removed. Okay, here will be spark, high heat created and material removed. This is the basic concept, but actually this is not like that. There is so many concepts inside it. This will be held by tool holder. Okay, this is tool holder. This is controlled by servo mechanism. What is the function of servo mechanism? This should maintain the constant distance between the tool and workpiece. Okay, for the machining process we are connecting, means we want the spark, means electric discharge. We want the electric discharge or spark. That's why we have to provide some current or voltage. Okay, that so we are providing voltage. Okay, tool to the positive terminal, sorry, tool to the negative terminal and workpiece towards the positive terminal. Okay, we are using like this. So this is tool positive and workpiece negative terminal. Okay, sorry, this is workpiece positive, tool negative. Okay, why we are connecting tool negative and workpiece positive, I will discuss. So this will be contained inside a container. Okay, we are taking this is inside a container. This is the workpiece holder. Okay, I will describe in the slides in details. This is the basic concept. that cannot be told there. So I am discussing here. So this is workpiece, and your negative and positive terminal. When the voltage is supplied, this is positive, negative. You know, current flows from negative to positive. So electron flow from here to here. Okay, and we are using dielectric fluid here. We are using dielectric fluid. Okay, this is a container, and we are using dielectric fluid. What is the function of dielectric fluid? That will current, that will carry the electron passing through the tool towards the workpiece. First function. Second function is to cool workpiece and the tool. Okay, third function is to remove the debris or removed material from the inter-electrode gap. Means this is the anode, this is the cathode. Inter-electrode gap से this will remove the materials. Okay, so this is the function of dielectric. So what happens when the when the electron pass from negative to positive? Okay, here electron will be pass from negative to positive during the propagation. This is the tool, this is the workpiece. Here electron will flow from negative to positive. During the flow, this will bombard with dielectric fluid. Okay, and you know, because this is filled up by dielectric fluid. Okay, when this electron will flow towards the workpiece, there will be, this will be bombarded with dielectric fluid. During the bombarding or during the strike, that will remove some electrons from the neutral particles of dielectric fluid. Okay, due to what? There will be number of electrons. Okay, there will be more number of electrons or a high number of electrons. Due to the high number of electrons, there will be high number of electrons. This high number of electrons creates the spark. Okay, here the spark is created due to this. Okay, this is the basic concept. That's why the spark is created. Okay, and due to the spark is means high heat. Due to the high heat, metal will melt and evaporate. Okay, and this is not a continuous process. Okay, this is not a continuous process. This is a series of discrete process. So first, this is the T on. Okay, T on period, off period, on period, off period. If this is the T on, pulse on time, this is pulse off time. That's mean we are not providing voltage continuously. First provide sometimes some microsecond. Okay, sometime voltage, then we will not provide any voltage, then provide voltage. Okay, voltage, then not voltage, then again voltage. This is a series of discrete spark. Okay, means we are not providing voltage continuously, rather than discrete. Means again pulse on time, then pulse off time, then pulse on time, pulse off time. This will repeat. Okay, like this. So, and due to this pulse on time, the metal will melt and evaporate, trying to evaporate, but cannot be totally evaporate because of this dielectric fluid. Okay, and a fresh dielectric fluid will be poured here. Okay, that is called flushing. Fresh dielectric fluid will be spread here, means will be provided here, so that in the pulse on time the material melted. During the pulse off time, what happens? That will try to evaporate. Okay, but that cannot be evaporate because of this fresh dielectric fluid. That will cool the evaporated particles, and that will prepare small debris. Okay, this will be small debris that will come downside, because the dielectric fluid that will come downside, and that will be filtered. Okay, here there will be one filtration system, and that will be filtered. Okay, so this is the concept, and this servo mechanism maintain the distance. Okay, this is called spark gap. Okay, this distance called spark gap. Constant gap is maintained. Okay, between the tool and workpiece, this constant gap is maintained. Okay, this is spark gap. Okay, who will maintain this? This servo mechanism. This servo mechanism will maintain the spark gap between tool and workpiece. Okay, when this will move from this position, this material is moved, then this will move here. So this total surface is machined. Otherwise, we can prepare, if the tool is like this, the job will be like this. This will be the cavity. If this is the workpiece, this is the tool, the shape will be like this. Material will be removed continuously, and when some material is moved, this will come downside. Okay, then some material is moved, this will come downside, like this. This will maintain the servo mechanism, maintain the distance. Okay, let's go our slides. I will discuss everything in details. One minute. So this is our EDM machining. We are going to discuss about this advanced manufacturing process, history of EDM process, process parameters, classification, advantage and disadvantage, application, developments of EDM process. Okay, I will describe everything in a small time. Okay, don't worry. This is all the slides. If you want to prepare in the exam, sorry, not exam, prepare, you can prepare also details. And if you want for the just like the final year PPT presentation or anywhere you can present it. Okay, so first of this is related to discharge machining. I told machining, what is machining, and non-traditional machining can be divided into three types like this: mechanical material removal process, thermal material removals, chemical and electrochemical material removals. These are the different thermal, mechanical, chemical, electrochemical, mechanical removal process, material removal process. Then this electro discharge machining process is developed by Joseph Priestily. Okay, okay. This first developed by scientist Joseph Priestily in the year 1878, and this is suited for machining of titanium carbide and superalloy like inconel, because these are very hard material. So one thing I forgot to tell, in this process we are not need to consider any hardness of the workpiece. Okay, rather than in traditional machining process, we are considering here. In case of traditional machining process, what happens in traditional machining process? One is traditional and non-traditional. In case of traditional machining process, we are choosing the tool according to the hardness of workpiece. Okay, we are choosing the tool according to the hardness of workpiece. But in case of non-traditional machining process, we are not considering the hardness of the workpiece. Okay, we can choose any tool. So this is the main difference between traditional and non-traditional machining process. So in electric discharge machining process, we are not considering the hardness of the workpiece or melting temperature, because we are getting very high temperature, just like 10,000 to 1200 degrees Celsius. Okay, so this is because this is this is costly process, and rather than the traditional process, this is very costly process. So we will use where we cannot use the traditional machining process, or where we cannot get final accuracy or higher accuracy by the traditional machining process, we can use there. Okay, so this is mainly suitable for intricate shapes and contours. Okay, intricate design. Then this is the, as I told, the material is removed by the means of this series of discrete sparks. Okay, this is the series of discrete spark, material is removed, and the shape will be replica of the machine tool. Okay, I have discussed this. Okay, pulse on time, pulse off time. I have discussed machine cavity. Next thing, what is the machining major components? Major component is machine tool. This is the machine tool. Okay, here we have providing the dielectric fluid, and here also dielectric fluid is present. Okay, and this is a tool control by the servo mechanism. This can move vertical. Okay, then work positioning unit. This is the work positioning unit. If you can want to move, then you can also move the work job. Okay, so this is the fixer. Okay, fixer or a job holder. This is our job. Okay, and as I told, tool is connected negative and work is connected to positive. Okay, and DC power is supplied. You got me? Then I told there will be one filter. Here is the filter, here is the filter, and here is the pump. Okay, pump will supply the dielectric fluid, and here filter will filter the debris. What to filter? Debris means the removed particle will be filtered here, and this dielectric fluid will again supplied here. And what is the dielectric fluid? Dielectric fluid may be deionized water, kerosene, and just like paraffin oil, then transformer oil, like this. And in case of wire EDM machining process, generally we are using deionized water. So what happens here, as I told, suitable voltage applied, then between tool and electrode, then electrons will lose from the surface of cathode and impelled towards the anode under the influence of field force, means we are providing the voltage. So while moving the inter-electrode space, electron collide the neutral molecules, as I told, detaching the electrons and causing ionization. At some time, the ionization because such that narrow channel of continuous conductivity is formed. This is nothing but a spark, okay, and the resulting momentary current impulse or discharge. Discharge means this is the spark. The liberation of energy accompanying the leads to generation of extremely high temperature, causing partial vaporization. But why this is called partial vaporization? Because here the melting, due to the heat, material will be tried to melt, but this cannot melt because of the phase dielectric fluid. Oh, okay, so this is partial vaporization. And you know this figure, okay, this is the workpiece, this is the tool. There will be material removal from the tool as well as workpiece because of the high heat, but there is only less material removal from the tool because we are connecting tool to the negative terminal and workpiece to positive. That's why electron is propagated towards the anode. Anode means workpiece, and due to the bombardment, more material will be removed here, okay. That's why we are connecting negative to the tool, positive towards the workpiece. This is our concept, that's why we are using okay. So high heat created, and this is the dielectric fluid, and a spark is created and material will be removed, just like this. Here small material will be removed. Then okay, there is also another concept is some scientists also provided some another concept. What is that concept? That concept is when here, okay, this is the tool, this is the workpiece, this is the tool, okay. Okay, when there is the plasma channel means continuous conductivity formed, okay. When there is continuous conductivity formed, there is some dielectric fluid. That dielectric fluid also try to evaporate, okay. Here, okay, this dielectric breakdown means that will break down and try to evaporate, melting and evaporating. This dielectric fluid will try to evaporate, and after some time this will be melted pool expansion of bubble, okay. This will be bubble expanded, and this dielectric fluid form bubbles, okay. After some time these bubbles will be collapsed, okay, and due to the collapsing of bubble there will be create some cavitation like from effect, okay, and due to that the material will be eroded, okay. When the bubble will be collapsed, here when the bubble is collapsed, material will be eroded like this, okay. This is a bubble, this is an interval, okay. So what is demerit? The main demerit is the cast layer or heat happening zone or white layer, okay. This is called, this from microscope view you can see, okay. We are provided in 500x, okay, 500x in zoom, so you can see where what is the figure, okay. If you see, just like you can think, due to the heat, more heat, the material is removed and the surface is looking like this, okay. This is a inherent phenomena. So scientists are trying to remove this white layer. We don't require white layer. So in this case, in EDM machine we cannot get higher surface finish. Higher surface finish, mirror surface finish we cannot achieve, but surface finish we can achieve for general use, because this is the surface, general surface is this, okay. But if you zoom it 500x or 500x, this will look like this, okay. This is at my higher material removal, this is my MTech thesis, okay. This is at the time of higher material removal, okay. When you melted and higher material removed, this is surface will look like this at 500x, okay. So this is the cause of white layer. What is the white layer? Heat from subsequent flushing and molten material on that will leave some unmelted material whose property is changed, that is called white layer, okay. This white layer can be divided into three types, okay. And you can see it, this microscope view, this is the white layer, Okay, microscope view. This is white layer. Okay, so what is the process parameters? The time is short, so I am going to discuss in a very speed manner, so please cooperate with me. So supply voltage, charging distance, charging resistance, capacitance, pulse on time, pulse off time, gap distance, direct flow rate. So when the pulse energy will increase, material removal will increase like this. Capacitance, when the capacitance will increase, then material removal will like this. Then current density, when current density increase, material removal like this. When resistance, resistance means this is the we are stopping this, so resistance increase means the material removal will decrease, means resistance means that will resist. So what is the classification? Classification EDM process, you can divide into sinking EDM, cutting EDM, grinding EDM. Sinking EDM also divided into two types, and cutting also three types, grinding also three types. But generally highlighted area is this die sinking EDM, okay, and this wire cutting EDM is very famous in EDM process. Okay, for material cutting we are using wire cutting EDM, and for die sinking we are using die sinking EDM for make the shape. Okay, you can see you can drill by the use of EDM tool. Okay, here the material, here the tool, we can drill by the use of EDM tool. Here die sinking, this is the die sinking process, and this is the, you can see we are cutting the material by use of rotary discs. This is the rotary discs. By the use of rotary discs we are cutting the material, and we are slicing by use the ribbon, then by cutting by use of wire, then grinding external surface, grinding internal surface, grinding this surface. Okay, so mainly two types, two is highlighted, this is die sinker EDM and wire cutter EDM. So die sinker EDM used for producing blind cavities, and wire EDM for cutting application. This is the die sinking EDM. Okay, here the tool, this will go downside and this will create the cavity. This is called die sinking EDM. Okay, so in place of long tool we can also provide this portion tool, so that the external part will be removed. Are you getting? If the tool is more, the material will be more material removed. This will take more time and more debris. But instead of that, this solid tool we can take hollow tool. Okay, like this. We can take hollow tool, so that we will create inside. The inside part will be removed. When the inside part is removed, that part can be removed easily. Okay, so you can use hollow tool also. And the wire cutter EDM, this is my project. Okay, wire cutter EDM, passing of upper guide, lower wire guide, and this wire will be continuously passed, and this will cut the material. Here just like see, this is the lower portion, this is upper portion, the workpiece is settled here, and this will cut the material. I am going to show in a video. Okay, you can see here, this is the machining. Okay, here the spark, you can see the spark. Okay, here the spark machining. Due to the spark, material is removing, and the dielectric fluid is provided here. You can see the dielectric fluid. Okay, this is wire cutter EDM, so we are using dielectric fluid, means deionized water. Okay, in case of wire EDM we are using deionized water. Here deionized water, a spark is created, material is removed due to this. Okay, this is the concept. So next slide. Advantage. What is the advantage of EDM process? EDM process can be applied to all, and this is one of the demerit is, we can use only the conducting. We cannot use non-conducting because we are providing current. If this is non-conducting material, then we cannot provide the voltage or current. So non-conducting material cannot be used here. But some developments is there due to developments. That is, one development is electrochemical discharge machining. That is one of the hybrid process I will discuss later. So EDM process can be applied to all electric conductive material, is irrespective of their strength, hardness, toughness or brittleness. Anything, we are not considering that. Any material you can take, that should be conducting. There is no direct contact between tool and workpiece, eliminating the mechanical stress during machining. Okay, edge and sharpness can be possible. Tool making easier, complicated shape is produced. Okay, and disadvantage, as you know, this is the material removal is slower means lower than traditional machining process. Recast layer inherent, as I shown here previously. This is applicable for non-conducting material, not applicable for non-conducting material. Rapid electrode wear, as I told, there will be some wear in the electrode. Then surface finish means we cannot achieve high surface finish. So what is the application? Application tool die making industry for cutting and extrusion dies, and these are the applications. Okay. So developments of EDM process, as I told, in some cases this is the demerits. Due to the demerits, scientists discovered some other topics, other methods. Means in the hybrid process, they go for hybrid process. Okay, by mixing the EDM process some other process to achieve some advantage. This is the abrasive electrical discharge machining process, or AEDM, abrasive electrical discharge machining process. This is also called powder EDM. Okay, we are using also abrasive powders. Spark is created and we are using abrasive powder, due to which we can reduce the electrode or the tool wear. Okay, and increase the surface finish, and the affected layer will be crackless, and this by using this process we can provide electric discharge coating also. Okay, so this is ultrasonic EDM. As you know, in case of ultrasonic machining process, we are providing vibration, and this EDM discharge means spark. We are mixing both and preparing another some hybrid process. So due to this, we can reduce the white layer, we can reduce the micro crack, and increase the MRR, material removal rate, and increase the fatigue life. Okay. Then magnetic force assisted EDM also developed, that will increase the MRR and surface finish. There we are using magnetic force to remove the material from the inter-electrode gap. Okay. Then wire EDM, there is some developments in also wire EDM. There is one wire EDM and a wire sawing, wire electric discharge dressing. Then micro EDM, for micro tool we are using micro inserts. Then abrasive electrical discharge grinding, AEDG. Okay, used for grinding purpose. This abrasive electrical discharge grinding used for grinding purpose. Then electrochemical discharge machining. This electrochemical discharge machining, as I told, we cannot use non-conducting material. Here we can use the non-conducting material, because your chemical reaction is also occurred. This can be named also by different scientists by different names. This is the electrochemical discharge unit setup. Okay, so this is main property. We can use non-conducting material also. Okay, suitable for non-conducting materials like glass, ceramic, quartz, granite, like this. Okay, so thank you everybody.